So if you don't know me, I'm a principal developer advocate at AWS. I have spoken at this group before, last time in Manchester. So it was cool, and I think I spoke about 19 things you didn't know about Visual Studio or something along those lines. Today I'm going to be talking a little bit more, a slightly different topic. It's about my exploration into Blazor. Now I've been building for a long time real-time applications, and if you've seen some of my talks before, you probably will have seen some of the real-time applications that I've built before. And I wanted to the things that I've generally done before have been done in Vue.js or Angular or some kind of JavaScript front end framework. And so I was kind of interested in Blazor and thinking about, well, how could I use Blazor perhaps and some of my .NET knowledge in exchange for some JavaScript frameworks. And so really this talks about looking into Blazor. It's my first sort of kicking the tires of Blazor and integrating it or trying to recreate an app that I've already built previously in JavaScript. Blazor is an interesting technology, and we'll be looking into a little bit more detail about the pros and cons of the different methods of hosting and stuff. But like for me, it's really exciting, the concept of being able to build something in JavaScript, in C# and not using JavaScript at all. Now the reality is, however, and you'll see this as we go through, you actually still do need a little bit of JavaScript knowledge, especially when you're trying to do integrations with different things. So it's not completely getting rid of JavaScript, but I have got to a point with this application where mostly it's all written in C#. Not only is the front end written in C# and the back end written in C#, also the way that I construct the infrastructure. I use a framework called CDK, which is using C# to create my infrastructure as well. So literally every part, from the CI/CD to the front end to the back end, there is pure C#. With one slight exception where I have to use some JavaScript to do some interrupt stuff. But very shortly, Steve Sanderson has shown me a way that I can remove that piece of JavaScript. So hopefully, very soon, this will be completely C#, this application. And I'll also be able to remove everything but, it would just be C# and HTML fundamentally, and some CSS, obviously. So there's some questions already, .NET North Live. Someone else is asking whether or not there's going to be this session's recorded. Everything on Twitch is recorded, so you can go back and watch it for a few days. And I'm sure we're going to be it's going to appear on YouTube basically when it's downloaded and put back. But you can, it will be hosted here for some time. Every time we stream on this channel, it's automatically saved and it's available a couple of minutes after. Okay, so if you do have any questions, by the way, put them in the chat window. I am constantly monitoring that. So if anything comes up and it's timely, I'll try and deal with it there. Will this be server-side or client-side Blazor? It will be client-side Blazor. I'll be talking about the server-side aspect of it as well. But what I've built is using server-side Blazor. Client-side Blazor. Gosh, that's confusing, isn't it? As a question, Lee, are AWS hiring .NET developers? Or Amazon hiring .NET developers? Yep, we are. So if you're interested, then do come speak to me. But most of our engineering happens in Seattle, but there are certain global jobs are available in .NET, depending on what focus you have. So, by the way, I gave this talk originally at NDC. I'm hoping not too many of you attended that session at NDC because it's generally a repeat. I've updated it slightly, but it's fundamentally a repeat of that session. But hopefully this option gives you a way of maybe interacting with the session a little bit more and asking some questions. So please do if you wish. So I'll just to sort of level set what I mean by building a real-time application. I want to create sort of real-time interactions happening in a browser. So what we're doing right now on Twitch with the chat, which is happening, that's a real-time application. Twitch is a great example of a real-time application. Not only are they streaming next to real time, they're like 3 milliseconds to 15 milliseconds, 3 to 5 seconds latency on the video, but they've also got that live chat, which is synchronized with the video. Even on playback, the chat's synchronized with the video, and it's happening in real time. So you people, as you're chatting on that chat site, that real time notifications are happening. And now the way that that's happening, it's using real time web technologies, but it happens all over the place as well. So like notifications, banking alerts, news story updates from news websites, when you're in multiplayer games or virtual reality experiences, You can, by the way, we do have a virtual reality experience which someone set up for this very event. I'm not sure if someone wants to paste the URL into the chat window for us, but Simon did set up is it called Alt Live? I think it's called Alt Live, like space, where you can actually virtually watch this talk if you want to watch it with other people. But that's a virtual reality scenario, and all of the different notifications as where the people are in that room and that space. All of that stuff is happening and using real-time technologies to achieve that. So thank you, Pete, for putting the Alt VR URL in there. Alt Space VR is the name of the service, apparently. Thank you, Lee, for telling me that in the chat. So, you know, another real common scenario for real-time technologies is document collaboration. So if you use Google Docs or Microsoft Office and you're writing a Word document and you invite other people to it, then they can start interacting and creating a document with you. Now, the underlying technology of that is going to be using some form of real-time technology. In the case of Office, they actually use SignalR behind the scenes. And in the case of Google, they probably use something, you know, I don't actually know what language most of the Google stuff is written in. So, but it will be some real-time framework probably that they're using. So those are the kinds of experiences I'm talking about. I caveat, every time I talk about real time, I caveat that I'm not talking about like trading applications or anything like that. So the scenario I'm putting together is purely for a sort of interactive real time experience delivered on the web or a mobile application. It's not how you would deliver, you know, a trading application where you have to get sub 100 millisecond latencies. Apparently, the Alt VR, by the way, according to the chat room, might be a little empty at the moment because Simon, the creator of that room, has also had to drop out just because of frame rates dropping. So it might be a little empty in there, but I think that's probably for next time that we do this live stream. It will be really cool if we maybe got that VR aspect of it a little bit more involved, because I think it would be quite a cool thing to do a meetup, but also a virtual meetup as well. You might have seen this on like hotel booking websites. Now, when you go to book, remember when we used to book hotel rooms? When you book a hotel room, it would say just booked in London, 52 properties like DoubleTree. That like alert comes up and tries to encourage you to go and book. Now that's meant to be, the way they could have implemented this is, you know, there's a lot of activity on this page and that's a real-time notification. The reality, it's probably just like a JavaScript timer, which is Shopper showing up a little bit of UI. But you know, let's imagine that the engineers are going to be doing the right thing, and if that site was particularly busy, they're sending you real-time information to try and encourage you to buy from them. We have this document collaboration system at AWS, which it's called Quip. It's from, I think, Salesforce, and it's a bit like Google Docs or Office. When I joined AWS, it was the first time I've actually used it. It's document collaboration, just like Google Docs, I guess, and it has features just like Google Docs. And one of my favorite features is the viewing feature. So when you're looking at a document, you can see all the other people which are viewing it. And of course, that's using real-time technology, like real-time stuff happening. So as someone logs in, it sends a notification somewhere that they've logged in. We record that, and then we send it to everyone which is connected to that document at the same time, so that they can see who's viewing that document at the same time. This is really good if you send out a document, and then you like, it's really important, and then you go to it and you know that nobody's viewing it, and that's always unless, like, what I often do is, if you do want to send a document out and you want people to actually look for it, what I tend to do is go, hey, I've just finished this document. It's all the salaries of all the other employees in the company. And you find that people then go and read those documents and read those emails far more than they would do regular ones. So that's a kind of real-time scenario. In the same system, you know, they have a chat system, just like what you've got on Twitch as well. You can, if someone's typing, this is probably one of the most annoying pieces of UI I find, is people typing. You know, you don't know what they're going to say yet, but they've clicked their keyboard, so that's sent a notification to the system. The system's popped up the UI that someone's typing, and so you're just waiting for them to type, and then it disappears when they don't actually complete their sentence, and it reappears when they start typing, and it disappears. So that can be quite good UI or useful UI, but it's interesting that you know that people are interacting with the system, and what that's doing is basically providing feedback inside of an application that something's happening and that there's activity going on. And that's a really good example of using real-time technologies to kind of subtly improve an experience. Now, the general way that all of this technology is working is probably if you're using a mobile browser or a client application or mobile application, you're connecting to a server and you are basically creating a WebSocket connection. Now, the way that this negotiation happens when you establish a WebSocket connection is that the application sends a HTTP request over to the server, and then the server says and asks basically the question, do you support WebSockets? And then the server responds, of course, it's 2020, of course I support WebSockets. And then because both parties both support WebSockets, then they upgrade the HTTP connection to a WebSocket connection. Now, WebSocket connection is basically a duplex network connection. It's like basically a socket between the client computer and the server. And you can communicate and send information back and forth through that, low latency. The advantage of a WebSocket is that when you're sending information over a WebSocket, you're not having to establish or send over the HTTP headers every single time. So you don't need to, every time you make a HTTP request, for example, you are sending over all of the cookies, all of the headers and all that stuff. Well, a WebSocket is doesn't require any of that. Once it's established, you're basically just passing back and forth the data, which makes it really, really better. So some of you may know a framework in the .NET space called SignalR, and this is where I got really interested in real-time applications and developing them back in 2009 was when SignalR was kind of becoming popular in the .NET world. Now, SignalR makes this stuff super easy and building real-time applications really easy. And it's particularly easy if you're building a SignalR application where you have one server, a single server, and multiple clients connecting to it. And back in 2009, that was pretty common. The fact that your web application consisted of a single server. Things do become more complicated when you have a load balance collection of servers, which is much more common in 2020, where we have where we're sending communications. Because when I talked earlier, I said about the WebSocket. That is a connection between one single client and one single server. And so when we have a load balancer, which will basically reroute requests to different servers based upon whatever, depending on the algorithm you're using for your load balancer, you could end up at a different server, which you actually haven't got a WebSocket connection established with. And so those sorts of issues start arising when you're doing this stuff at scale. SignalR has nice ways of solving that though. So SignalR, I'm not going to go too much into it, but it's supported in .NET Core as well now. And it's still a really efficient way to do real-time stuff in .NET. So when I joined AWS, I'd already built this sort of SignalR voting application. And I thought it was a good idea to see how would I go and publish this to AWS? What would I use? Now there's a service at AWS called Elastic Beanstalk. Basically, Elastic Beanstalk is a service which manages a load balancer and a bunch of machines for you. So you basically give your code in a zip file effectively. You do it from command line, but it's passing over a zip file, and then it deploys it to a bunch of machines and puts a load balancer in front of it. So I thought this was a good example, a good challenge for Beanstalk was to see how I would set it up so that I could get SignalR working. Basically, I did this. I set up it's got a load balancer set up with two machines, and actually an auto scaling group saying I want between 1 and 5 machines. And depending on the load, it will scale up or scale down the number of machines on the back end. So all I do is I say I've got this service. I'm going to pass it a zip file which contains my .NET application. So this Elastic Beanstalk's been around since 2009, 2010. And it's before Docker containers. So we now have obviously containerized services where we send a container, but this is predates that. It's a bit like the Azure app service, web app service, if you've ever used that. So we publish our zip file to Elastic Beanstalk and it deploys it. So I built a SignalR application, I deployed it, and this is roughly this application. So if you've got a phone on you at the moment and you scan that URL there. So let me do that now. So on my iPhone, I can open up the camera and I point it at the screen and it opens up signalr.thebeebs.net. So you could just type that URL in there, signalr.thebeebs.net. and you should have like a please wait screen on your device. Hopefully a couple of people have got a please wait screen on the device. So then I basically flip over here and ask a question: coffee versus beer. Oh, so people are connected because 5 people straight out of the gate voted beer. Coffee. I've just looked on the viewers. There are 72 of you online at the moment, which is awesome. And we've got at least half of those people have voted. So some people are voting coffee, some people are voting beer, but beer is generally in .NET North a more popular thing. So that's cool. And I'm going to ask one other question. It's controversial. Tabs versus spaces. Now what you'll see is that the question on your phone should have automatically changed to tabs versus spaces when I progressed the slide. When you're clicking the button, the tabs or the spaces button, it's automatically updating my screen. And all of this is happening over WebSockets. So if I just open up a developer tools window, somewhere on the network channel thing, I'm going to have to refresh it actually. So tabs are more popular, by the way, in .NET North, but I'm going to lose some of that because it doesn't cache any of it. There we go. And what we'll see down here is a negotiate request. So this is that negotiate that I talked about, the HTTP request. So there's some kind of thing which sends over, it gives it a connection ID and says what available transports it's got. And if it's successful, it will set up somewhere here, it will set up a request, and this is a WebSocket request. And you'll see there the request URL is WebSocket SignalR-thebeebs.net voting hub, and then it gives an ID to it. And you'll see that there's oh, that's weird. Let's see. Let's ignore that for the moment. Seems like it actually seems like it's gone through a different mechanism. That's one of the cool things about SignalR actually. If it doesn't establish a WebSockets connection, it will fall back into another thing that it can do. So whether that be server sent events or long polling or whatever, that's what it seems to appear to have happened at the moment. Never mind, it's still working. And you'll see that all of the information is getting passed back and forth. So as people are voting on this application, it's sending messages back and forth over that transport. So let's come out of there. So our application is working. Now we have 75 people which are viewing it, and we have currently 105, 106 people which have voted on this application. Someone has recognized that the security of this application is not particularly good, and you can refresh the page, or you could also just send me lots of requests as a DDoS. So someone's doing that, which is quite cool. But let's ignore that for the moment. So that's kind of the application that I built. That's actually in Vue.js, by the way. So that screen is in Vue.js, and it's connecting to a WebSocket using SignalR. It's not doing anything particularly complicated, and but it's all in .NET on the server side and JavaScript on the front end. So that works, and I can publish that to a single machine and it will work pretty well. But there will be a problem if I've got more than one server on the back end there. And what we do to solve that problem in SignalR is we create a thing called a backplane. And the reason why a backplane is required is that when a request comes in to our server, it will connect to one of our servers. So maybe this one over on the right. It will establish a WebSocket connection. Now, next time a connection is made over the network, perhaps the load balancer will connect us up to the other machine. So we're going to have this problem of connecting to different machines. So we can solve that in a load balancer by saying create sticky sessions. So a sticky session will basically send the user back to the same server every time. But then let's say we're building a chat application. One of the problems will be the WebSocket connection will, when a user sends a message, it will be sent to this particular instance of my application. And so everyone which is also connected to that same server will receive the messages that I send. But anyone which is connected to this server, they won't receive those messages. It's because basically these are separate applications that don't talk to each other. So SignalR has this concept of a backplane. Real-time applications have this concept of a backplane. And it's usually implemented in SignalR, we usually implement it using Redis. Redis has a really cool pub sub mechanism, which SignalR takes advantage of. And basically in Amazon, we have a service called Elasticache for Redis, which is basically a managed Redis service. So I can create one of those, and then in my application, I have to put in this piece of code in my .NET application. So when I add the service for SignalR, I .add Stack Exchange Redis. I provide a connection string to my Redis instance, and I say I create a little channel on my Redis. So basically, it's the subscription channel, and just by adding that, every message which comes into each server is basically rebroadcast via the backplane to all of the other connected servers. So you end up with a messaging system now which spans multiple servers. So it doesn't matter if we have now 1 or 5 servers, messages getting passed back and forth, and that works really well. But the problem with this scenario is stuff just got expensive, right? We've got we've got the application, and we're hosting that. We're paying for all the different servers, and now we're also adding an Elasticache for Redis on the back end of that. And we've got to manage that cache cluster as well. We have to over provision that perhaps. Elasticache for Redis does scale automatically, elastically, but it's an expensive service ultimately. So if I want to create one of these real-time applications, like this silly demo application that I just built there, and then I have to, push an Elasticache for Redis because I want to support a number of people, because you'll see a server can only really, let's say it can only handle 1,000 people connected to it actively. It's fine if I want to use it in a demo and a talk, but if I actually want to use it more broadly on the internet and I want to support 10,000 people, then I need 10 machines, and then I need an Elasticache cluster which is going to handle that, and it starts getting really expensive just to do something quite straightforward. So I kind of wanted to do another way of doing this. Now, last year, AWS launched a service called API Gateway with WebSockets. Now, API Gateway has been a service which is around in AWS for a long time. And what it basically is, it's like, imagine it as like a proxy for your APIs. So you can create your APIs and you can create them in whatever you want. And then you put this gateway in front of it, and you can use that as your sort of interface to the application. So a lot of our customers will use API Gateway to consolidate disparate APIs. And they'll consolidate it, and they'll sort of do all of the cleverness to sort of map the incoming requests to different services and different systems, and give their customers a unified API, when actually behind the scenes there's lots of APIs that they're using. You might use it to sort of add authentication to an API or something like that, and those sorts of things. So API Gateway is really popular, and it's really popular for generating these APIs, but the kind of the support for WebSockets just came out just over a year ago. And WebSockets now, what they've said is, not only do we support HTTP requests, we also support WebSockets. And this means that we will maintain WebSocket connections for you on your behalf. And then when requests come in, we will route them to your actual API on the back end. Now, I've talked to you about WebSockets before. WebSockets are stateful. API Gateway previously was not stateful. It was, a request would come in, there'll be some pattern matching, it would pass it to the correct API. But it wasn't stateful in that it wasn't maintaining socket connections to users. And so to enable WebSockets, you have to do something interesting to try and kind of support this concept. And what the basic premise of this service is, okay, they're going to manage all of the connections for us. They're going to maintain all the connections for us in these WebSocket connections. And we're just going to develop APIs, and they're going to be called as if they were REST APIs, but the WebSockets and the sort of statefulness is going to be maintained and managed by AWS. So this is the service, Amazon API Gateway. This is kind of the model that you have. So mobile applications on the left-hand side here, chat applications, dashboards, IoT devices, they have a stateful connection to API Gateway. And then API Gateway gets a message from one of these devices, and it sends it sort of as a proxy almost to either a Lambda function, to a virtual machine, to a service like Amazon Kinesis or any other AWS service for that matter, or any other API that you might host anywhere. So you might host it, as a URL in Azure or in some other system, some other cloud system. So API Gateway maintains the stateful connection and then just sends RESTful message requests to the different services. So the way that this kind of works is your application on the left-hand side, it connects to the Socket Gate API, and it receives what it's called a connection ID. So each user will have an individual connection ID, and API Gateway is going to maintain that. So the connection exists between API Gateway and the devices, and then when a message comes in, API Gateway invokes, let's say, a Lambda function, or it could be a container, or it could be an API, but it's a Lambda function in our example. But it passes along a connection ID to the Lambda function. When someone connects to my API, what happens is they execute something, they connect to the WebSocket, and the WebSocket URL is just like WWS, something unique, execute API, the region which it's hosted in, amazon.aws, aws.com, and then the stage that I'm using. They connect to that WebSocket URL using the WebSocket client in either JavaScript, in .NET, in Java, in whatever, if they're building Android applications, if they're building web applications, they'll create a WebSocket connection. And that exists in pretty much every client application, client sort of SDK. So create a WebSocket, point it to that URL. The gateway service will establish the WebSocket connection. And then when you send a message, it will end up on my API looking like it's being evoked RESTfully, but with a connection ID. So my Lambda function, if you send 3 messages via the WebSocket, I'll actually invoke the Lambda function 3 times, but it will be invoked with this connection ID, so I know who's calling it. Okay, so as messages get passed, we call them, in real-time frameworks, they call them frames. So as these different frames get passed between the applications and the gateway, that basically starts invoking my Lambda function. So if it was passed 3 times, then it will invoke my Lambda function 3 times there. So my Lambda function is not connected to your client. It's completely restful. It's not like this, completely stateless, sorry, not restful. It's completely stateless. And so it's just getting invoked with connection ID. What I do on connection is I store all of the connection IDs in a DynamoDB, so that I basically have a database of everyone which is connected to my service. So when you connect, you have a connection ID. I store that away in a DynamoDB, and I store it in a DynamoDB because Lambda functions don't have any persistent storage. They don't have any way of I could be hitting a different one every single time. So I store them in a DynamoDB just to have a persistent record of all the connections which are currently established. Now, that's the client can call the API gateway and invoke my functions. But how do I then, from my Lambda function, how do I speak to my clients? Because that's what real-time communication is all about. It's like this duplex communication. And the way it works is that a Lambda function can call what we call a connection URL. And this connection URL is specifically designed to basically be like your unique code, execute API, the region that it's in, Amazon.com environment, then it says connections, connection ID. And if you post from a Lambda function or from anywhere to that particular URL with the correct connection ID, and then you send that to Amazon API Gateway, it will then route and proxy that message back to the client. So your Lambda function just needs to know, or your piece of compute just needs to know what connection ID it needs to talk to, and then it can individually send a message to those different connections, and it sends those individually via these connection URLs. So this is kind of what I've set up in my application. A connection URL is quite cool in that you can do a few things with it. One, you can post a message to it, so we can send a message from the server to the connected WebSocket client. We can get the status of the connection of the WebSocket client by doing a GET request to that URL, or if we do a delete request, so instead of a post or a GET, we do a delete request to that connection URL. It will disconnect that user from our service. So over on the dashboard, we can create an API. This is how you would create an API in AWS. I want to create a WebSocket API. I give my API a name. This is a recording of that thing, by the way. So I create my API and I say a route selection expression. And I say, well, whatever's in request.body.message. Oh, I've spelled that wrong, but I'm sure I fixed that in a minute. Request.body.message. And what happens is when a request comes into this API, it's going to look at that request body message in the header, and it's going to basically forward anything with connect in the request body message to a Lambda function called onConnect function. Disconnect we'll put through to a Lambda function called onDisconnect function. Now I'm forwarding it to a Lambda function here, but I could send it over to a HTTP request, a different AWS service, a HTTP endpoint, a mock endpoint if I wanted to, if I'm just sort of developing it. I'm going to add another route called send message, and I'm going to put that to the send message function. Okay, so now I have a connect, disconnect, send message action, and then I can deploy that API, give it a name, call this prod, because I'm pretending I'm putting it to production. The question from the chat says, can these WebSocket connections go through API or gateway authorizers? Yes, they can. So we're going to, now we've got a URL, a WebSocket URL, and we can take that URL and you can see there's also the connection URL as well. So the WebSocket URL is going to sit there, and I can now put that in from my application and use it in my application. And basically, if my application sends a message which is constructed a bit like this, so message which says send message, and the data is hello.net north, then it's going to use that message filter to figure out which route that it's going to send it to. So this is going to say send message, so it's going to say, okay, I need to forward this on to, and it's going to look at the send message route, and then it's going to forward that on to the Lambda function called send message, and it's going to pass hello.net north to it. So my architecture looks a little bit like this. I have an API gateway at the front, which is basically accepting or connecting my connections. And then I have 3 Lambda functions. I've got one called send message, one called onDisconnected, one called onConnect, and a Dynamo database. One thing which is quite cool about all of this is that I only pay for these 3 things if they're used. And the API gateway, I'm paying based upon the number of requests that I get through to it. So if my service doesn't get used, I don't really pay anything for this scenario. And this is why it's quite good for me with these sorts of real-time applications. And it can also scale massively. Like we use this for really major sort of, some of our biggest customers use this service. So you can scale this to massive levels of having lots and lots of concurrent connections to it in a way that would probably be very difficult to manage if you were trying to do that on something like Elastic Beanstalk. And if you were going to do that with Elastic Beanstalk and Elasticache, it would cost you a lot of money to do that. Like minimum, like the minimum demo that I do is like a couple of machines in Elasticache, and that costs me like 120 quid a month, and I'm not even scaling that. That's just tiny, right? But if I was to scale it, it would cost me thousands and thousands. Whereas with this, I get a million execution of those Lambda functions for nothing every month. So this service, when I use it, it costs me every time I use it about well under $1 pretty much every time I use it, and sometimes not even that, depending on if I'm still on the free tier. Whereas when I do the demo the other way, it costs me a lot more money. So you can build a lot less inexpensive and more highly scalable real-time applications using this architecture, even though it's a little bit more like cumbersome, I guess. Just to show you a little bit like what's in that function, that Lambda function. So send message, what it does is it takes in the request which comes in on line 41. So I basically take the deserialize those messages which are coming over, and I do a scan request on DynamoDB, and basically I get a list of all of the different connections. So every connection which is in my DynamoDB table, I basically put into an array effectively, or a list. And then I can post to that for each item. So for each connection in my DynamoDB, I can post to that connection asynchronously. And what that means is that when someone sends a message, I loop through all of the currently connected clients, all the people which are connected, and I post them individually. I send them a message, and I use that connection URL, and I post that connection URL. And basically I'm able to create this sort of chat-like scenario where a message gets sent, one person sends it into my system, and then my other Lambda function will then distribute that out to all of the connected clients. So you're able to get a real-time application, even though the Lambda functions don't even realize they're kind of real-time, they're working in real-time. So just to show you this a little bit, if you're interested in joining in along with this demo, go to chat.thebeebs.net, chat.thebeebs.net. I actually was bothered this time to put on in HTTPS, but the other one you'll see in the other demo I didn't bother. Now it's going to come pre-pitted with a WebSocket connection. Just connect to that. Okay, and then you should be able to say and type stuff in. Hello. Am I the only one here? Oh yeah. Hello possums. Hello possums. Hello. And you'll see there's lots of people which are saying this is great. Here's me washboard. Hello. There's quite a lot of people which are chatting on that. So you can see you're basically going through my WebSocket connection there. I don't know if I got my console open. Let's have a look. API gateway. I think it's this one. So if you were to create a very similar system to this, so like a connect, disconnect, and send message, you can see it's like connected up to my Lambda proxy. I could go to the stages, go to prod, and you can see that there's the WebSocket connection URL. And that's basically what I pasted in here when I sort of connected to the server site. So you can paste those things in yourself. If you were testing this and building your own application or a similar application, this is I have this here so I can test my application. I pre-pid it with the URL that I've created for the event, but it should work and connect up to any system. So I've got some other chat. It's interesting that you're more active on this chat than you are on the actual Twitch chat, which is really odd. So show us the COBOL. Interestingly enough, if you are interested in COBOL, and I'm sure some of you are, there is a support now. There is a unofficial support in Lambda. You can write serverless functions in COBOL. So if you wanted to, you can do that. Generally speaking, though, I'd rather write them in .NET. You can use obviously any language, .NET, Go, PHP even. Node is one of the most popular things for Lambda functions. Python, another really popular one. You prefer Azure? Oh, well, never mind. I'm sure a lot of people do. So, I work for AWS. I used to work for Azure. It's fair. It's fine that you prefer Azure. I don't mind. I'm not here to try and convince you otherwise. Just to mention that Azure don't have quite the same service as this. They do have a similar service for SignalR, though. They actually have a thing called the Azure SignalR service. It's different to this because it's specific to SignalR, but it works in a similar way, I guess. It's a managed WebSocket service. Twitch chat rocks, but Beep chat's better. Yeah. Oh, emoji. I didn't even realize that I've added emoji support, but I guess I didn't really have to do anything to add emoji support, but I'm going to pretend that was a feature that I had to add. That's cool. So tonight's drink is whiskey and Coke. Someone's had whiskey and Coke tonight. I've actually got a Diet Coke. That's what I'm rocking tonight. Don't really drink anymore. I've got a Diet Coke, and then I've got a tea in case things get bad. We probably have to ask the rest of the organisers later on what they're drinking tonight. But in fact, put in the chat what you're drinking tonight. It would be interesting to know. Yeah, show me the Blazor. I recognise that. I should get to the Blazor point, and I will. I promise you. See, I told you I was going to get to Blazor. So Right, Blazor. I'm pretty new to Blazor. Peter Vic's got a Corona on the go. Rick's got cider apparently, so that's cool. And Christopher Walters got water, and I don't know what that is. Scary looking. Never mind. Blazor. So you've got two hosting models with Blazor. One which is currently like available. One which is called Blazor Server, and I think I should have probably checked this before. But Blazor WebAssembly, when I last checked, wasn't production ready, but it might be. Correct me in the chat if it has been launched. It is GA, but I don't think it is. But Blazor Server is GA, and the concept is similar in that you're able to write front end applications using C#. With the WebAssembly model, what happens is the WebAssembly model basically executes your C# application inside the browser, and it's using some really smart, clever stuff in JavaScript, available in JavaScript, to basically run and execute languages which aren't natively supported by JavaScript. And so it's using a technology called WebAssembly. It's actually running mono at the moment. I'm sure that might change when .NET 5 comes out. And I can't remember. I can't keep up with the names. But right at the moment, mono is kind of the thing which is actually being run to enable the WebAssembly integration with Blazor. But the idea being that stuff all happens on the client side. So you're in a browser and your UI thread is executing and running WebAssembly, and you're effectively, as a developer, you feel like you're writing C# code. Now, Blazor Server has a similar experience, but it's doing something a little bit different. Rather than executing and running the C# code in the browser, it's sending it over a low latency SignalR connection back to a server. The server's processing it, and then it's passing it back. Now, in this model, in the Blazor Server model, theoretically, you could manage the servers or a fleet of servers, and you could manage the SignalR connections. But I think the reality with Blazor Server is that I wouldn't want to do it without using the SignalR managed service. That's kind of the way that Blazor Server works. And so at AWS, I'm certainly thinking and asking some of the product teams, like, could we have a similar service, maybe a managed SignalR service? We don't at the moment, but SignalR, so Azure, for me, Blazor Server, you can get it working and running locally. You can certainly even probably get it running in production. But I think like Blazor Server, generally, you need to use a SignalR service. But the kind of experience for the developer is the same. You rent the server-side code in the client, and the server-side code on the client and the server code is all written in .NET. But the Blazor Server model is kind of got this kind of slightly weird tunneling where it basically executes on the server and then renders it on the server, then executes it and sends it back to the browser. So it doesn't work for things like offline applications. So if you're building PWAs or browsers which might be offline, or Android applications which you're putting a web client through and which don't have a constant connection to the internet, then you're like Blazor Server is not going to work. But if you're building sort of like intranet-based applications which don't have huge scale, then Blazor Server is probably going to be fine and work really well for you. So I can imagine that being used like on admin screens and intranet sites and stuff like that. It would be a really good fit for that sort of workload. But Blazor WebAssembly for me is like the really interesting thing. It's like, finally, I can execute Blazor WebAssembly anywhere where JavaScript is supported, and also WebAssembly supported. And so for me, I wasn't really that interested in developing stuff in Blazor Server. So I was interested in Blazor WebAssembly and how we would get that working. So what I wanted to do is basically I wanted to recreate what I'd already built in Vue.js and create that in WebAssembly using that using Blazor, and then using also that API gateway thing that I talked about. So it does get a little bit confusing because I just mentioned there that like the server Blazor that uses WebSockets. But that isn't real. It's not doing it for real-time purposes. What it's doing for is getting the benefit of the server being supporting the C# stuff. And so you could build real-time applications using that, but like that's not the primary reason that they've got SignalR in there. The primary reason is to be able to like generate the code and the views that you're looking at. So what I'm going to do is build a WebAssembly Blazor application. and then I'm just going to integrate it using WebSockets as you would a Vue.js application. So I went to the Blazor website, and it showed me like the getting started, and that's literally my experience with it was this. I'd seen Steve Sanderson talk about it when it was its inception. He actually spoke at my event in London. It was called a JavaScript Day in London in 2015. And he did a really amazing talk in 2015 where he showed compiling some C code into WebAssembly. And he said that was like the inception of like, I wonder if I could get like a managed language compiled down into WebAssembly. And then he went off for like a couple of years, developed it in private, well, not in private, on publicly or open source, but he did it pretty much on his own. And then he pitched it inside of Microsoft, and it became a fully fledged product. So, you know, it's cool that it's like, it's developed from just that sort of, could I get this working, into a full product, which is now very close to GA being supported fully. And Rick just said Steve Sanderson is a genius. He is a genius, a complete genius. And what's cool about Blazor, and one of the reasons why I think it's got real legs, is the fact that Steve Sanderson's not new to single page applications. If you have ever used Knockout, like Steve was behind Knockout.js back in the early sort of 2011, 2012 timeframe. And so he's got form for developing really good SPA applications, and lots of that knowledge and stuff has been brought to Blazor, I think. And also he wrote the MVC3 book for Rock's MVC3 book, which is one of the classic MVC books. Anyway, so I did what everyone does, which is I go and .NET New, and I downloaded the Blazor templates. And this slide's a little bit old now; it's a few months old. I actually haven't updated the application to anything new. There are some new things that have been added and stuff, but so this is the version which I was using when I created it, and then I created a new Blazor WASM application, so Blazor WebAssembly application, and called it my real time. So these are the two commands that you'll need to run to sort of basically install the Blazor templates, and then instantiate a Blazor WASM. Once you've done that, you can instantiate a Blazor WASM application. It will give you like a boilerplate application. Obviously, you'll need .NET on your machine. I did all this on a Mac. It's all cross-platform, obviously, because it's using .NET Core. Also, Rick, you mentioned that Steve Sanderson is a Brit too. Yes, he is a Brit. He works for Microsoft still as a developer, but still from the UK. I think he's in Brighton. So he's one of the cool folks which have got an engineering job at a major US corporation while still living in the UK, and I think that's the best way of doing it. So I've installed that. I've basically got then a basic application. And so my application's in this folder called front end. And it looks, when I looked at it first, it looked to me like a Razor, an ASP.NET Razor Pages application. In the, you've got some pages, and it's got index.razor, questions.razor, vote.razor. We've got like a shared folder like you have in MVC. We've got a www root folder. And anything in the www root folder, that's like you would put like your assets, your CSS, your images. In this instance, I've got some questions that I want to store somewhere. In the actual production version of this application that I will eventually get around to writing, I won't be storing the questions in a JSON file in the service, but it was quite handy just to add them here. I'll probably put them in a database. But let's just say for the moment I've got a questions.json. It basically has those two questions that I asked earlier. I've got tabs versus spaces, or coffee versus beer. And really the only details that I need to store are these ones, like answer 1, answer 2, picture 1, picture 2, and answer count on both of them. So I've stored that information to get my questions. And then I looked in the pages folder. Now the index.razor pages, that's what loads up when you start your application. So we've got a hello world, welcome to our new application. And it's got this construct, this thing called a survey prompt. And it's got title, how is Blazor working for you? You'll see that in Blazor all the time, is that you'll have like these components, which are basically hiding more complex stuff. We won't get into components at the moment, but this is a component. This survey prompt is a component. And you'll see it in the demo application. It's basically like a banner up the top, which says, how is Blazor working for you? And if you click on it, it will then take you to some place where you can give feedback about Blazor. It says, hello world, welcome to your app. It's using because of the way where it's located, it's using a shared wrapper to give it sort of its styling. But fundamentally, the pages look really simple, right? I've got hello world, I've got a little bit of text, and then I've got a component called survey prompt. So what you can do, I basically just then went and created another page called questions.razor. And in questions.razor, what I've done is I've imported the data when the application initializes. So I say, I've got this object called questions, and I'm going to call a HTTP API and get this sample data.questions.json. Now, obviously, I'm loading it locally from my machine, but this could be a URL to an API to go and get this data. It's just loading it directly off my machine at this moment. But you'll see that I'm doing a HTTP request in C#, and this is going to execute inside the browser. What's cool about that HTTP request is that it's not actually using the network stack for .NET when it compiles. There's a really clever injection that they've made, which actually means that will go through the networking stack of the browser. So when I do that await HTTP get JSON.async and I'm in C# and it actually runs, that will actually go and fetch it, and you'll be able to see it in your Chrome DevTools just as if it was a HTTP request. And in fact, it is a complete HTTP request in the browser. So that is one example of where they've made it extensible. They've gone into the HTTP element and they've basically put in a little link back to the browser's networking stack. They've done this also for WebSockets, and I'll get to that a little bit later. So you can do stuff in C# which you might not expect to be able to do, like there's not like a networking stack available, but it's actually routing it through the browser's networking stack. So on initialization of that view, I call that API and I basically get back my questions. It parses it from JSON, which is what it's into a hard JSON, into a hard questions class. So I've got that class underneath it. It's got an ID, title, answer to, answer picture one, whatever properties on them. And so I basically get a list of questions back. Now, what I can do on the actual Razor form is I've got this hard C# object, and the UI is going to react to that object. So I've basically got here, it said H1 questions, and then I say if questions is null, so if that object doesn't have anything in it, I'm going to just print the word loading. So it's going to put loading on the screen. And when that question object sort of gets data, print a table out. Now, the first things it's going to do is just going to print out the header for the table, title, answer 1, answer 2, count 1, count 2. And then it's going to go and loop through all of those questions. You just want to see, you see that thing at the top of the on line 2, inject HTTP client. That injection is really important because if I don't do that, it won't do that intercept thing that I talked about. So that's the way you sort of inject the HTTP client into that particular. So if it's a bit like a using statement in a regular C# file. In a Razor view, you can inject different C# modules or packages into your page using that. So I've injected the HTTP client because I'm going to be using it. And then basically on line 24 here, I for each the questions, and basically it says if the particular question that I'm looping through is the current question, then print that out. Else don't print it out. So if I've got a list of 4 questions here, and current question is set to 1, then then it will show just that particular question. So it's only ever going to show one question at a time. What's cool about this is if I increment this current count number, if I increment that to sort of 3, it will show me the third question. So I've got this mechanism of basically saying, well, only show me the current question. one of the current questions. Loop through all the questions and show me one of them. Now, the cool thing is, if I modify the questions object in C#, it will reflect automatically on the screen. So as I get new data into the questions object, it's going to expand that, and it's going to basically redraw this screen for me. So I don't need to repaint the screen every time I get new data. I just need to modify the data, modify the questions object, and my UI is just going to automatically update and reflect that. So I basically print out the current thing, and I've got two things here down at the bottom, which are buttons. Basically a button, and this is a CSS class. Hopefully you can see it on the screen, you can. And then I've got this on click. And what this is saying, it's kind of the way of saying, when someone clicks this particular HTML element, it's going to actually execute some C# called previous question. And on the other one, it's going to execute some C# function called next question. So here we go. So if I look at my code, you'll see that I've got a code block underneath the buttons. I have my private questions object. I've got the current count, which is currently set to 1. And then I've got this private void called next question and previous question. And all the next question and previous question do is it changes the current count. So if I click next question, it increments current count, so it adds numbers to it. And if I click previous question, it removes numbers from current count. So it basically goes up or goes down. And I've got a little bit of logic just to make sure it never goes past the maximum or lower than the less. Now, every time this is clicked, it's going to change current. And because it's changing the current count, it's going to change which question is being displayed. So I just modify my C# objects, and somehow my JavaScript, my sort of HTML and C# are being effective. Now, this is exactly how a JavaScript application, single page application would work. But obviously I'm not using JavaScript at this point, I'm using C#. So, so this is what my application now looks like. I've got this question. It's showing the current question. So tabs or spaces, answer 1 tabs or spaces. And when I click previous or next, it's incrementing that current count. And basically that's affecting the UI. You'll note that I didn't update the UI. I didn't say, once I press next, then update the UI or make a change, or I didn't change the table. I just basically created that code on the front and then tied it to these objects. And then when I modify the objects, my UIs automatically reflects what I've changed. So I've got the questions screen, so which will show the questions, but then I need a voting screen. So I need a screen where people on their phones can click one or the other things. So I've got it's a very similar page, the vote page. Again, I'm just looping through the questions, which I currently have. But I've also added some buttons, and it's saying if you on-click that one, it's going to vote for answer 1, and if you click that one, it's going to vote for answer 2. I've got the previous and next question buttons. In the real application, the users don't have the ability to switch questions that they're on, but I've just left them in for the time being. The way that the actual system really works is that when I change in the question screen, I send a notification to the vote screen to change the question. But for the moment, the user is in control of that. So now on the vote screen, so I've got a question screen and a vote screen, and now the vote screen, I've got 2 buttons that if I click on one of them, they do nothing at the moment because I've not implemented them yet, but that's going to allow me to then vote and call my WebSocket URL. So what I want them to do is when I basically press answer 1 or answer 2, I want it to fire off a WebSockets notification to my service, and then that will then get broadcast back to the other application. So I spoke to Steve Sanderson at NDC about this, and the way I currently do it is I use JavaScript interop because there wasn't, at the time that I wrote this, any way of creating what I expected to be able to do was basically what Steve Sanderson's now saying I can do, which I've not actually got working, but apparently this is how it works. So you'd expect in C# if I wanted to make a connection to a WebSocket, I would just do it how I would do in a console application. So I could write a C# console application right now today and create a new white client WebSocket and basically send messages to that WebSocket and get alerted when messages are received by it. But you can't do that, or you couldn't do that previously when I was trying this. It didn't work, it didn't compile. But this is the code that should work, and I'll be hopefully implementing this code very soon. Basically, you create a WebSocket, a new client WebSocket, and then when the page loads, you connect up to the WebSocket. So this would, So this would connect up to my WebSocket URL. And when you send a message, you can basically send a message to the WebSocket. And when you receive a message, it comes into the WebSocket. Now that's cool and it would work, but I've not got it working. So the way I did it was a little bit more complicated, but it does show you a little bit of the power of Blazor in that what you can do is you can sort of integrate with Blazor and JavaScript, regular JavaScript. So I knew how to do this in JavaScript. So what I did is I have this line on initialized. Instead of connecting to a native WebSocket application, I say invoke a JavaScript function. So I basically can, from C# invoke a JavaScript function. And this JavaScript function basically invokes something which is running in the browser. And it's saying connect it to this particular URL, and then give me a reference back to that object. And if that's connected is true, then that's great. And I display on the screen that it's been connected. So I'm basically invoking some JavaScript to actually connect to WebSocket. On the actual page, I've got this piece of JavaScript. Now, you might be thinking, I thought this was meant to be writing all C# and I would never have to use JavaScript. What I've discovered about Blazor is that you actually do need to write a bit of JavaScript, especially if you want to interact with existing JavaScript objects. So if you've got like a JavaScript library, which you might want to call, there's a good chance that that's probably not already been ported to Blazor. It could be, but it's not, maybe not, but you might want to interact with it. Well, you could use this method, basically. What I've done is I've created a number of helpers, and this helper, I've got a connect function. It can connect to a WebSocket, and then it can basically give me an object, a C# object back. And when a message comes in on this socket, it invokes some C#. So you'll see that I've got a .NET object reference invoke method on vote. So basically, when someone else votes, I get a method invoking which will invoke the C# function as well. So then I've got this C# function back in my C# world, which is JS invocable. And basically this means that JavaScript can actually invoke this function. And so when a message comes in off the WebSocket, it calls this C# function on vote, and then it basically adds the question, the answers and the answer count. It increments the answer count with the questions that have come in. And then I call this thing called state has changed. State has changed is a way, if you do want to say, right now, refresh the screen based upon the current state of the objects. You can call this thing called state has changed. Sometimes Blazor doesn't pick up that you've modified, especially when you've come off when you do it with this JS invocable. I've discovered that it doesn't necessarily realize that the C# objects have changed. But if you call state has changed, it kind of like tells the system, like, please note that all of these different objects have changed, so redraw the screen for me. So it just does it's just a way of forcing a redraw of the screen. So I modify the questions and then do a redraw of the screen. So I added this little extra thing to my API, a vote mechanism. I won't go into the code, but basically it does this. When you click that button, it sends a message called vote, which sends it through to the vote route. And then it says the question ID, and it gives you an answer, the answer that they chose for that particular question. That particular vote thing goes through to a Lambda proxy function. This is my vote. I'm not going to go through any of this code, but it basically stores records the votes and the people which have voted for it. So this is basically this is what it took me a while to figure this out. Actually, is that you can quite easily, when a message comes in, it will execute you can execute C# from JavaScript and back and forth. I don't think in my application I shouldn't need this, because I should be able to not use JavaScript at all and just use a native WebSocket connection to connect to the WebSocket. But at the moment, this is the only way I got it working. So what I should end up with now is, in my application, on the vote screen, when I click on the vote, it will send a message to my WebSocket. At the moment, I've not got any restrictions on how many times people vote, but the user can move to different questions and can vote on different questions, and you'll see that it's being passed over to the browser, and stuff's being passed over to my WebSocket as I kind of want it to be. So if I look at the example in two browsers, and as I'm voting, the question screen gets updated. So all of my WebSocket sort of wizardry is kind of working, and it's doing as I expect it to do. All of these screens are being updated mostly by C#, but I've got that little bit of JavaScript which I've had to use as well to kind of achieve some of that stuff. So like in kind of summary, Blazor WebAssembly is really cool. You can start using JavaScript, start using C# to build sort of UIs. So if you're familiar with single page frameworks like Vue or Angular or React, Blazor is potentially a replacement for those sorts of things. There are a few caveats to it. One thing is that you'll find that you pay a penalty when you load the application in the first time it loads. You've got to remember, if you actually look at what's being downloaded to the browser, you're actually passing over DLLs. So you'll see DLLs being sort of sent and served by the system, and it's got to bootstrap the sort of environment. It's got to start running C#. It's got to load in the DLLs to memory, and so the sort of initialization and startup of WebAssembly, Blazor WebAssembly, it takes a little bit of time. So you have to wait a few seconds for the screen to sort of show. So again, like if you were building an application and you have to wait 1 or 2 seconds for the application to load, some people might think that that's unacceptable. And so that's one thing that you might have to think about, is sometimes these applications are really easy to write, but the actual experience of the first view of that page is actually a little bit poor sometimes. Oh no. So you should be able to scan this particular thing and then vote for this session. Let me just check this here, if it's working. That's unfortunate if it's not. Rate my session. This session is no longer accepting ratings. I'm really sorry about that. I don't know why. I didn't write the system for rating the sessions, and they've just added this new feature which says that people, when they scan that code, they can feedback on the session, but you also get some AWS credit. But for some reason, I think that there might be a problem with the timings that I set up on that. So I apologize that QR code is probably not working very well. I'll fix that and send it out via the meetup group. I'm sorry about that. But Blazor, it allows you to build C# applications. There are some caveats and some drawbacks about it. It does take a little bit longer to load when you're building your first application. But it's very good if you're a C# person, you like C#. I would strongly recommend trying it out. And I think for kind of applications, particularly internal applications, and that's generally speaking, most of the applications I see in .NET are usually internal business tools. This is a really, really productive way to sort of produce those sorts of things. And I'm really interested in sort of moving forward with it and trying it and developing more about it. And what I'm seeing is from people like Telrec, and I don't even know what they're called anymore, but all the components vendors, they're starting to build out components that you can start using in Blazor applications. So if you want to use calendars or grids or things like that, then that's all becoming available as well. If you're interested at all in helping me with this application, I'm going to try and develop it into a fully blown quiz system in Blazor. And so if you're interested in developing it, then do hit me up on GitHub, and you can join in the fun when I open source it. That is all from me really today.